So, hey everyone, welcome to our live YouTube session. That is the first session of the mini series that we're going to have on artificial intelligence, machine learning, and deep learning. Before we begin, as always, I just want to ask and check if everybody can hear me properly and see the screen. You guys can just let me know by one text in the live chat. We're going to have a very interactive session of this mini series that we're going to have on ML, AI, and deep learning. So I hope everybody can hear me properly, and I hope everybody can see the screen as well. Perfect. Very glad to hear that I'm audible and the screen is visible as well. So let us go ahead and let us begin with this first session of this series. So the first thing I want to begin with is many of us have some confusions on this. Many of us think the word artificial intelligence, the word machine learning, and the word deep learning are very, very similar. Many of us get confused by these three terms. So today we're going to take a look at these terms and we're going to try to create a good meaning out of it and get a really good idea as to what they are. I'm glad that a few of you from our previous batches have also joined. So Gopi Krishna has joined and many of you. So let's go ahead and let's begin with this. So the first thing I want to begin with in our today's first session is what exactly is AI? Now, just to note, this is going to be a mini series for an entire week or so where we're going to go through a lot of different topics in the advanced fields of artificial intelligence, machine learning, and deep learning. So, one of the first things that are important is what exactly is artificial intelligence? To answer this particular question, we have to go back 60 to 70 years and look at a computer scientist whose name was Alan Turing. Now, we're not going to have a history lesson, of course not. This will help us define what is artificial intelligence. So, Alan Turing was a famous computer scientist, crypt analyst, and he was into a lot of things when it comes down to computer science. Now, in this particular scenario, he created something called a Turing test. This is to help identify whether an application truly has artificial intelligence or not. That is identified by Alan Turing using something called a Turing test. So, Turing test is just a little test where there's a person called a tester, and this particular tester will interact with a system having artificial intelligence as well as another human. Now, this person is not able to see them. This person can only interact them through a keyboard, a terminal. So, when the person, or in case as we call the tester, interacts with the application as well as the human, if the person is not able to differentiate between the application and human, then you can say yes, that particular application has artificial intelligence because it confused the tester enough to assume that it is actually a human. So this is the kind of test that was created to identify whether an app can disguise itself as a human or not. So the original Turing test was where there were three terminals. So there will be one tester and there would be three different terminals. Two of those terminals would have human members and one terminal will have an artificial intelligence app which the person would chat with. And if the person is able to understand which of these is not real human, then it's not having artificial intelligence. An app is said to have artificial intelligence if it mimics human behavior. That's the key definition. That's the basic definition that we need to know. So this is what we call as artificial intelligence. It's just any application which can mimic human behavior. So you may be wondering which kind of application passed the Turing test. Again, this is just one graphical representation of the same. The tester will just be able to communicate with either the system as well as the human using a computing interface like a keyboard where they can type a certain message and the computer would respond. One of the first ever applications that passed Turing test was ELIZA. A lot of 90s kids, a lot of early 90s kids used to have ELIZA in their computer, and they used to chat with this particular bot which would respond nearly as a human. You can still find this online. It's still available for free. Since it's such an old application, it's completely available for free. I just want to show you one conversation that happened between ELIZA and a human. So ELIZA was literally created as a psychotherapist application, again back in 1960s, right? So this particular app goes like this. It asks, is something troubling a person? The person responds, men are all alike. Probably they went through a breakup. You never know. So the app asks, ELIZA asks, what is this connection to you suppose? So the person responds, they're always bugging us about something or the other. So the app responds, can you think of a specific example? So all these sort of things which a human would generally speak is what this particular application is speaking, is what this particular application is responding as. So this is how we can get to clearly know and understand that yes, it mimics human. And unless I told you that it's an application, you may think that this is an actual human conversation. That's how Turing test actually works. Now, just as a fun fact, there's one more conversation if you'd really like. If you type something which doesn't have any meaning, it just says, "I'm not sure. Uh, I understand you fully," and so on. So it's a pretty advanced app, advanced chatbot for its time, which responds very well. Today, you have a lot of things like Alexa and all those things which are similar to this. But just remember, a Turing test is where a human is unable to distinguish between an artificial intelligence app and a human when interacting between them. So this is a human testing whether a software is a human or not. On the other hand, there's something called a reverse Turing test. A reverse Turing test is where a software tests whether another software is a software or a human. You may wonder that this seems crazy, but it's something we see every day. You may have seen these captchas that you have to type because a website doesn't want something like distributed denial of service attacks, right? So to ensure they don't get distributed denial of service attacks, websites have these captchas where humans have to prove that they are humans by selecting these images or by selecting images of boats or mountains and so on. So if it's not a human, then of course a software won't be able to do this. This is a reverse Turing test where instead of a human unable to distinguish between, let's say, a software and a human, here the software should be able to distinguish between a software and a human. So I'm just giving you as an example for us to understand it. So there's a lot of artificial intelligent creations that we have in real life. Let's say self-driving cars, which automatically get to decide what is ahead of it. Is there a stop sign? Should I stop at that stop sign? Is there any place where I should slow down because other vehicles are coming along? So many things are often figured out. So many things are often seen here in real world scenarios where we use artificial intelligence. But this comes to a question. If artificial intelligence means that it's any application or any software plus hardware combination which mimics human behavior, it mimics a driving behavior of a human, right? It stops when there's a stop signal. It goes when it's supposed to. It stops when there are other vehicles around. It behaves similar to a human. So a person outside may think that a person himself or herself is driving this car. That's how we get to figure out that it has artificial intelligence. If you're unable to distinguish it between humans and, let's say, a software itself. So now comes a question. If artificial intelligence is that, then what is machine learning and deep learning? Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. This is something most of us are confused with, and this is where we need to learn and understand this very well. Artificial intelligence is where an application behaves as a human. Machine learning is a method to implement artificial intelligence. Deep learning is again a technique to implement machine learning on the other hand. We're going to take a look at machine learning and deep learning in detail further on. But in our session today, I want to focus mainly on artificial intelligence. When you talk about artificial intelligence, we divide them into three types generally: narrow, general, and super intelligence. I'm going to explain each one of these in detail, or at least in brief, so that we get to know which one we see in real world or which one of these we see in real life generally. So let's take a look at this. The first one I'm going to point out to is something called artificial narrow intelligence. As the word suggests, narrow, your artificial intelligence app is supposed to do only one task. It doesn't do anything else. You cannot ask your artificial intelligence application to do everything in the real world. It cannot perform everything. It cannot go and book a ticket for you. It cannot drive a car. It cannot do everything. It can only do one task. Let's say an artificial intelligence software which only does one task. It has no sentiment, no emotion, no consciousness like a human, but it's able to do one task. For example, if you have an artificial intelligence application which can play chess and a person is playing chess with it, if it's done through a software, a person cannot figure out whether he is playing chess through an uh, artificial intelligence app or with a human. It cannot figure out because artificial intelligence app playing chess are also that well made. So this helps us understand that these are particular artificial intelligence application which perform only one operation or only one task and they don't do anything else. So these are narrow intelligence. This is what we mostly have in the real world. We have every artificial intelligence, 99% of artificial intelligence applications, whatever we have in real life is based on this. I'll just give you a couple of examples. Take a look at this. Facial recognition. You're recognizing someone's face using a software. It uses artificial intelligence to figure it out. Again, it does only one task. Self-driving car. It does only one task. Chatbot. It does only one task. Siri, Google Assistant, or Alexa, whatever it does only one or two, a few tasks. It cannot do everything. Although they are trying to make it as human as possible. You can ask Siri and Alexa to tell you a joke and everything. They are trying to make it as humanly as possible. But it's still not at that phase yet. So you can just understand how or in what phase it exactly is. Now, moving ahead from artificial narrow intelligence, we go into something called artificial general intelligence. This is where an application is able to learn and act like a human being. So that means you cannot distinguish between human and machine whatsoever. If an artificial intelligence application is put on a human, is put on a human skeleton kind of fake thing, and you're unable to figure out whether it's a real human when you talk to it, you won't get to know. There are such things created in the world right now. Sophia is an example of an artificial intelligence robot which feels like a general intelligence app because it behaves like a human. It has facial reactions like a human. All of this are exactly like a human. So if you'd like to go through more about it and learn more about it, you can check more into it. You'll definitely find a lot of things. But another example I just want to take is most of the times it's only portrayed in movies, apart from the example that I took up. Let's say this particular robot, R2D2 from Star Wars, for example, or many sci-fi movies where there are robots which act exactly like humans, in movies with Will Smith and let's say Tom Cruise, all these sort of movies where there are robots which act exactly like humans, often portrayed in sci-fi movies, is what we have as artificial general intelligence. Followed by this, we have something called artificial super intelligence. This is what a lot of computer scientists are literally afraid of, if you ask. So this is the AI which surpasses human intelligence. It's so much better than human intelligence that it can make decisions for itself better than humans could. So this is what computer scientists feel, that if there is artificial super intelligence at any point of time, it may decide that humans have the ability to shut it down and it would in turn end mankind. So again, it's just a far-fetched theory. We are nowhere close, but it's just something that's existing in theory. So greater problem solving and decision making is something better than humans that it can literally perform. That's something you can literally perform through this. Anyway, moving ahead from this, One of the simple examples, we don't have real world examples of artificial super intelligence, but one of the examples in theory that I can give you is of the Terminator, which can literally take decisions better than a human. The Skynet and so on, all these sort of things. Again, we're going a little into sci-fi movies more, because in real life, what we have is artificial narrow intelligence mostly. We are currently tapping into the world of artificial general intelligence. We're just starting to explore it in real world. And artificial super intelligence is something we haven't even barely scratched the surface of. Now, moving ahead from artificial intelligence, if we talk about machine learning is just a subset of artificial intelligence where you can create your own apps which can perform a certain task. Again, when we talk about task, think of it as artificial narrow intelligence again. It's just an example of an artificial narrow intelligence scenario. The difference here is in machine learning applications, it is built on statistics. So all machine learning algorithms are built on statistics where certain algorithms are already created. You don't need to create any program. You just need to use the available algorithm. You just need to give your input to it and expect the output. Think of this. Till now, every application we ever developed, whether it's in our computer lab or whatever, wherever it could be, we are given the input and we are given the output in the program, that is in the question, and we are asked to create the program. We are asked to write the program which can get certain output for certain input. We are asked to create the program. If you think of Fibonacci number, you write the code of it. If you think of finding whether a number is prime or not, you write the code of it. Machine learning programs, on the other hand, you will just give the output as well as input to a machine learning algorithm. It itself will decide the code based on some statistical methods. That is what is machine learning. So in other words, all you need is inputs, all you need is outputs. You just give it to the machine learning algorithm. It will look at the input, it will compare with the output, it will learn from it, and it will create a method, or it will create a model, as we call in reality, where if you just give the input to it, it will automatically predict the output. You don't have to create the code for that purpose. So an example for this is something like, let's say, stock market analysis. If you just give the date, it will ask you, it will let you know whether the price of a certain company's share will be high or low or the same. So certain things are just a couple of examples where all you need is previous input and output data. With just this much, you can automatically have the algorithm create the code by itself. No explicit learning program you have to create. That is where machine learning comes in. I just want to give you a few examples of machine learning. You may have seen Spotify recommendation. In Spotify, the moment you listen to a few songs, it recommends you certain songs automatically. The moment you watch a video on YouTube, YouTube recommends certain videos similar to it later on because it knows you may watch it. The moment you see certain Instagram reels, the moment you see certain movie on Netflix or Amazon Prime, it suggests something very similar. All these recommendation systems are machine learning algorithm based, which have a statistical model behind them. And using that particular statistical model, they are able to figure out and let you know what you may like to watch. Again, nobody is writing the code for it. Somebody is just giving the input and output. Somebody is just giving input of some 1,000 people and what those 1,000 people liked as songs. And when you select a particular song, it compares with those 1,000 people liked songs and it suggests what you would like better. So you literally are not creating any learning code. You're just giving input and output to a particular algorithm, and the algorithm creates the rest of the code by itself. This is, in short, a small way to understand it. So when we talk about machine learning, there are different ways. There's something called supervised, unsupervised, and reinforcement learning. These are the kind of different classifications which we will see in the coming sessions. Again, today's main agenda or overview is to help you all understand what is artificial intelligence and how is machine learning a kind of artificial intelligence. So there are many types of machine learning classification techniques which we will see in time. Followed by this, If you want to go to deep learning is a part of machine learning. So just like machine learning, you're going to give your input and output, and it's going to use some statistical methods in order to predict, in order to create its own logic to predict the output. Deep learning is very similar. The only difference is when it comes to deep learning, it helps mimic a human brain. It's completely inspired by a human brain. Think of this. Whenever you think of drinking, let's say, coffee, if you smell coffee, a certain set of neurons in your brain fire up. They get activated. Whenever you smell tea, a certain different set of neurons in your brain fire up. So for each thing that you think of, each thing that you smell or taste or see, different neurons in your brain fire up, indicating that it is such a product or whatever it is. So a deep learning model, a deep learning algorithm is something that reflects human brain in such a way that it also creates a neural network. Just like when you smell coffee, certain neurons in your brain fire up telling you that it's coffee. Even in deep learning networks, there are something called neurons, and certain neurons fire up when certain inputs are given. If there's an image of a car, if there's an image of a bike, and you have already given certain images and the outputs of it to the deep learning model to learn from, later on, if you give any image to the deep learning model and ask it to predict whether it's a car or a bike, if it's a car, certain neurons fire up. If it's a bike, certain other neurons fire up. That's how it gets to know whether it's a car or a bike. This is just a bird's eye view of it. We're going to go ahead and take a look in depth about this over time, but I just wanted to give you a very small introduction to this. So some applications of neural networks are these. You have chatbot systems which are based on deep neural networks which understand what you're typing in order to respond. Self-driving cars like Tesla or Google cars, all of these are also built on neural networks. And sentence prediction systems, like if you have typed half the sentence, what would be the next word and so on, all of these are also based on neural networks. Again, we're going to see these in depth, in much more depth over in the coming sessions of this mini series that we're going to have. Moving ahead, just to point out, just like brains have certain neurons which fire up when certain trigger is created. Like the moment you smell coffee, it triggers certain neurons. The moment you smell tea, it triggers certain other neurons. These neurons fire up. The exact same thing happens even in this code, where a neuron firing up is identified by it being a value of 1, where a neuron not firing up is identified by it being a value of 0. There could be other values as well, but I'm just giving you a simple scenario, simple understanding on how exactly they are. So this is what is deep learning. So what we are able to see here is, in short, artificial intelligence is the domain, or is the technique, you can also say, where an application mimics human behavior and a person is not able to differentiate between human and an application. Within that, machine learning is a kind of, just to point out, is a kind of artificial intelligence system which uses statistical models, and deep learning is a kind of machine learning model which, along with statistical models, uses human inspired neuron concept to mimic that behavior in that way. So all of these so far, whatever we have in our real world till now, are only narrow intelligence. General and super intelligence are not really explored well yet. So when we talk about neural networks, just like we talk about, again, I did not point this out. When we talk about deep learning, we often associate with neural networks only. Because whenever we talk about deep learning, we are creating a neural network, an artificial neural network. A real neural network is a brain. An artificial neural network is something that is created in a computer which is supposed to mimic the neuron structure of a brain. So this artificial neural network is what is generally a part of deep learning, and all deep learning algorithms or deep learning models, we generally also call them as neural network models or neural network algorithms. There are multiple types of them. There are much more. These are just a few. Each one of them are used for a different purpose, like convolution is used for images particularly, recurrent is used for time series or text data particularly, and so on. I will be giving you guys a in-depth view on this in the coming sessions as well. But I just wanted to introduce you guys to this so far. Now, before we go ahead, just to point out, we also have a special internship course on machine learning, which is going to start very soon, possibly by November 25th. For registration details, we are updating it as of now. So probably in 1 or 2 days, you will be able to see the same updates in our website directly as well as our YouTube channel. So if you're interested in going through that, you can definitely do that. And these mini series are just a little taste of the full course menu that is offered as the internship course on machine learning. So with this, we will be ending this little session on introduction to artificial intelligence and machine learning and deep learning. So far, all that we are able to do is just understand the difference between AI, ML, and DL. In the next session, we're going to go in depth in machine learning, in depth in deep learning. We're going to look at some real world examples. We're going to look at some real world applications and see how exactly they work in the coming sessions. So stay tuned for the coming sessions of this mini series. And if you'd like to know much more about this, you can always go ahead and check for our internship details, which will be posted in a day or two. So I hope you guys had a fun time going through this. Now, before we end, if you have any 1 or 2 queries regarding whatever we just took a look at, only on these topics, I would love to answer them for a minute or two, and then we can go ahead with the end of the session. So I would be waiting if there are any queries that from your side, like is something considered as artificial intelligence, or is something not considered as artificial intelligence, or any such thing. I'd love to get your questions. I'd love to go ahead and answer those as well. Right, so it seems it's been a very effective way to do this. That's perfect. Right, so it seems that everybody is pretty clear. I have one question. How many days will be the duration of the internship? The internship will be pretty much a 3 month internship where we're going to divide it into 2 parts. First part will be your training. The first part of your internship will be purely training, where we're going to train you completely on basics of Python, the Python from very scratch, so that even if you're new to this, you can always start beginning and learning this. So we're going to be training you from the basics, from the scratch of Python completely until you're able to create your own deep learning models, including things like COVID data prediction, like whether we can expect a new wave or not, even things like Bitcoin prediction, even things like, let's say, stock market prediction or sentiment analysis. So many real world scenarios, real world applications we will look at, and all of these you will be trained on, and then you will be given a capstone project at the end to cap off this so yes, you're gonna go through a capstone project at the end of this to cap off your entire internship in style, because an internship requires you to explore and express your skills. That's why we'll be providing you with a capstone project as well, and that's going to help you out learn and understand machine learning and deep learning in much more depth. I hope that gives a fair understanding and idea. I have a couple of other questions. This course is planned to be a separate course apart from the portal, and the fee of this will still be, we'll let you know within a day or two. I have one question, very interesting question. Was Turing test successful? Absolutely, yes, it was. For certain applications, it was. Nowadays, instead of Turing test, we cannot always interact with computers with a keyboard. Nowadays, we interact with computers in various different ways. We have mobile phones, we have self-driving cars, we have automatic drones, we have so many different things. So nowadays, Turing test is not just about interacting with a computer. Nowadays, Turing test is about seeing something execute in front of you, whether it's a self-driving car or whatever it is, and see whether you're able to distinguish whether it's a pathetically built application or whether it mimics humans so well that you can't differentiate between human and the artificial intelligence app. So yes, Turing tests have been successful for various applications. Various applications have also failed Turing tests as well. If you go online, you can also check out something called, I think its name is Deep Blue, if I'm not wrong. This is a particular AI application which was able to defeat the world champion of chess back in 1900s, that is Gary Kasparov, if I'm not wrong. And this particular application was then decided to possess the skills of artificial intelligence because it mimics something as good as a human. So you can say that it does mimic humans as well. So Krishna states Sophia is a scam. Yeah, may or may not be. It's not a perfect artificial intelligence system. There's no artificial intelligence system that you can call perfect. It's still a program nonetheless. But they are trying to be as close to reflecting to be a human as possible. So I hope this little introductory session has been fun for everyone to go through. We'll continue ahead in our next session of this mini series. Until then, have a good time, and I hope the software and a few other things that we discussed in this session, you can Google it, you can go online, check it out, and be very impressed with them as well. So with this, we'll end the session here. So until the next time, have a good time and take